Okay, in this video I'm going to explore the three different states of matter. I'm going to talk about what observable properties we see with those states. Then I'll talk about what the particles are doing that's leading to those properties. And finally, I'm going to talk about why the particles are doing that. So first of all, with solids we have I'm on my eraser just a second. There we go. They have a fixed volume and a fixed shape. So a solid keeps its form. It doesn't really expand or contract that much. It will a little bit, but not too much. So it has a fairly fixed volume, and that's what makes it a solid. So what does that mean in terms of what the particles are doing? Well, the particles in a solid tend to arrange in a pretty orderly fashion. The location of these particles is not really changeable without a great deal of force that's changing the shape of the material. So they sit in the common location and just kind of sit in that one spot. They are pretty close together. And they have a fixed location. They can still vibrate. So it's not like they're just sitting there not doing anything. They sit in this spot and they go up and down or side to side and vibrate about that location, but their average position sort of stays the same. So they can go up or down or side to side a little bit and shake around in there, but they don't ever leave that spot. Sometimes this overall shape that they're in is called a crystal lattice. That doesn't mean that it's a perfect crystal like you would imagine with a diamond or something like that, but it just means that it's a regular repeating pattern that tends to hold its shape like that. What that means then is, since the distance between the particles is fairly common, that fixes the volume, and because the particles can't leave their spot in the crystal lattice, that fixes the shape of the material. Why would particles do that? Well, essentially what we have here is we have particles that are more attracted to other particles, I should say to each other. And they have more attracted to each other than they are moving. Does that make sense? What that means is they're not moving fast and they're really attracted to each other. Or another way to put it is they're not moving fast enough to break away from the lattice because of the high attraction. Alternatively, liquids have a fixed volume, but they don't hold their shape. They take the shape of the container they're in. Or we say they flow. What does that look like on a particle level? Well, the individual particles are still pretty close together, but the actual sort of crystal lattice that they were a part of before has broken down. So they stay close to each other, but they're not in this regular, orderly, fixed pattern. What that means then is an individual molecule can move from one spot to another spot. It's not stuck in this one location, but it has to stay close to the other molecules. So they're still close together. The distance between them being relatively fixed, meaning that they have a fixed volume. They can vibrate, and they can rotate around and take different shapes. They're not stuck in their one spot in the crystal lattice, but they're not free to translate or leave the material entirely. Here we have more of a even fight between the attractive forces and the motion of the particles. This means that the objects are going fast enough to move out of their location in the crystal lattice, but not fast enough to move away from the other particles. Finally, gases have no fixed volume and they take the shape of their container. This means instead of being clumped around, these guys actually spread all the way apart and fly about in random directions very fast. If they're in some sort of container and they hit the edge of the container, they will rebound off, but they're constantly flying around. They are not close together. And the space between them is not fixed. This causes the volume to change to whatever volume is available to the gas particles. It also means that they have a very low density. There are not very many particles for a given amount of volume. Why would they do this? Well, essentially this happens when the motion of the particles is much stronger than the attractive forces between particles. So the attraction between particles is low enough that they don't stick together. So there it is. Solids all clumped together in a nice orderly fashion. They have their fixed shape because the particles are stuck within their location in the crystal lattice. Liquids, similar, but they're still very close together, but they don't have that regular crystal lattice shape anymore. The particles have to stay together, but they can change their location within the crystal lattice. They can slide past each other. And gases, the particles don't even stick together at all. They fly about. Maybe the whole room is the container, and they spread out. They have very low densities, but also they have no fixed density because the gas will take on whatever volume is available to it. And it all has to do with whether the attractive forces between those particles are large enough to keep them clumped together, or whether they're motion is strong enough to allow those particles to break free of the other particles and fly around the room.